Okay. So we're going to introduce a few more terminology, a little bit more of terminology. And again, these are terms you're going to study in depth in later courses. Okay, and I'm mentioning these here because things can go wrong in your project if you're not careful about the kind of structures we create. Okay, so we're going to classify structures that we've got. So we've basically gone to structures, and we're going to classify structures into various kinds based on some of the terms we saw earlier, like root, leaves, and so forth. Okay, so let's go and look at the Cartesian plane we had, and a different kind of Cartesian plane. Okay, and this Cartesian plane had x-axis, y-axis, x-label, y-label, and these two properties. This particular Cartesian plane has my lines have become now the lines with points in them. Okay, remember I have two kinds of lines. One is a line that has x and y coordinates. Another is a line that has a point in it. Okay, and it's often useful to have a point because you can just refer to that location and share it among various objects. Okay, and that's what I'm doing right now. I've got x-axis and y-axis now have points in them. And what I do also is, in my top level object, I go and get the x-axis location and the y-axis location and store it as my own property also. Okay? So my get axis and y-axis have a point location each. Okay? And in addition, at the top level object, I have a variable and a property that basically store that point in a local variable. Okay? Is that something that's useful to do? I mean, you know, a lot of you will do it. I know. I mean, lots of people have done it in the past, so I expect this to happen more also. Can you see a reason why somebody might do it? I have basically two names for the same value. There is one location, and I have a name. I have a name within the line with object property, and I also have a name within the top level thing. Now, when you guys have folders, do you do something like this? Can you guys see the analogy between doing something like this in the with folders, having two names to the same file, and that's called a shortcut. So typically, often people will create shortcuts on their desktop. Okay, even if you don't create shortcuts on your desktop, they will have a favorites link which has basically these extra names to the files. Okay, so this is not something I like to do personally, but I know a lot of people will be doing this, and when you do this, you get into trouble. Okay, when you use ObjectEditor. Okay, so I want to basically point out what kind of trouble this can cause. Okay, and I'm going to use that as an excuse to show you some concepts. Okay, so basic point understood, that you've got the x-axis and y-axis, and the x-axis location and y-axis location are basically cached. That's the sort of technical term people use. I've got that in my top-level desktop object so that I can refer to them conveniently. I don't have to go and say get x-axis dot get location. That's too much typing for me. So I just go and say get y-axis location. Maybe that's my name is so long that maybe that was not less typing. Okay, but that's what I'm doing here. Okay. So that's what I'm showing. This is what has changed. And now I go and say, okay, x-axis location, I go and figure out what the values are. And so this is just my implementation, and the function goes and basically does the get and assigns it. Okay, so this is where I'm assigning it. Okay. And so basically I went and computed the x-axis location, and then I gave that value to a line, which went and assigned that object in its constructor. Okay? So the basic point, and this is something that you might think is convenient, that think of your avatar that you're going to draw. You know, you want to sort of perhaps have one location point for it, and have all the other locations derived from that location. Okay? Saying, whatever your avatar location is, I am this distance in the x direction and this distance in the y direction away from it. And every subcomponent could have this kind of formula in it. So they're all working from some root location, which is the common location. Okay? So this, in fact, makes for pretty clean programming if you want to do it. Okay? And that's why a lot of the students have actually done it. Okay? So that's what's happening here. Okay, I'm passing these two values to the line. Okay. Okay, and again, when we do this, if you're from MATLAB, you say, okay, whenever I go and pass an object, I get a copy of the object sent. No, you're getting, since this is an object, its reference is, we always think of it in terms of an address. It's the address that is stored in that variable, and it's that address that is passed on to the actual parameter, and it's the address that gets shared. Okay? So we are sending, this is like the shortcut, like we talked about, that we're sending links. We're not creating new files, we're just creating a link to the existing file. Okay? Okay, and I guess I'm showing you, again, they're not important. Okay? Okay, so this is what's going on here now. I've got this DAG Cartesian plane. I've got the x-axis and y-axis. And if I start displaying this, anybody want to tell me how the display might change? Because I have this x-axis location and the y-axis location property in the top-level object. So I'm still going to see my x-axis. I'm still going to see my y-axis. I'm going to see my axis length and length property. And I'm going to see the x label and y label. And what's ObjectEditor going to do with these two properties? Yeah. It's going to create boxes. Is it going to create boxes, or is it going to show them? So is it going to show them as a point? It's of type point with the annotation also. Okay. So a lot of students get irritated when this happens because they say, "Oh, my beautiful pictures got sullied now by having these points." Okay. So again, because ObjectEditor is trying to have these automatic rules, it gets into a little bit of trouble. You get into trouble. Okay? So that's what's going to happen in the graphical view. If I go and show the tree view, even worse things start happening. I have x-axis location shown, y-axis location shown, and my x-axis and y-axis have just disappeared from the tree view. Okay? So basically bad things have happened. Firstly, in the graphical view, two things I didn't want displayed got displayed. And in my tree view, okay, and this has to do with the name tree for this view, my tree view basically cannot show this logical structure. The tree view is supposed to show you the complete logical structure, and the tree view says, I give up. I can't show. I tried to show, and I encountered some part and where I had to give up. Okay? And it gave up basically right here when it had to show these two x-property, x-axis and y-axis. Okay? And so, how it gave up, is not that important. How you recover from errors, there's a zillion ways to do it. But the fact that it gave up, the fact that it didn't like what happened, is important. So why did it not like what we did? So what does the word tree mean to you? Okay, tree is a certain kind of structure, and can you imagine what constraints that structure has to be called a tree? When you think of a family tree, you can branch in one direction, and can you call it back, or basically there are two paths to the same node. When you call it back, it's a cycle. We didn't create a cycle, but what we did was we found two ways to reach at the same point, and then that's no longer a tree. Okay, a tree assumes that every child has a unique parent. It doesn't have more than one parent. And what we've done is have multiple parents. The x-axis location has got the Cartesian plane also as a parent, and it's also got the x-axis itself as a parent. Okay? So x and y-axis are not shown in tree view, and it said, look, I already showed the child once, and now, and you'll also get this error message, and this is again, if you get this error message, please, a lot of you will get this, and you'll say, what is this talking about? Okay, so please register this properly at this point. And it says, look, I gave up, and I'm going to tell you that there's something bad happened. That the same object can now be reachable from two different paths. Okay, so root is the root object that you went and edited. So you went and said, edit object. That's a root object. And you said, okay, the same object is root.y-axis.location, and it's also root.y-axis location. So I have two names, I have two parents, and I'm confused. Okay? So please go and fix your code so that this doesn't happen. And we'll see what the fix is. One fix is to not even program this way. Another fix is to have a little better dialogue with the object editor and say, this is what you should be doing. Okay? But see what the problem is, that we've got a tree. What this expects is a tree. And this tree view is created using some tree widget that I used from Java. Okay? And that widget cannot show a non-tree. And so when I take your structure, I go and decompose it, I end up creating a non-tree, and I give it to, and so this can't display it, and I detect that happening, and I go and give you this error message. Okay? So there are two questions right now, and I've forgotten which order I'm going in these slides. One question is, how can I have a little dialogue with ObjectEditor to say this shouldn't happen? And the other is, let's get into a little theory of various kinds of structures. What are trees? What are non-trees? So I think I'm going into theory next. Okay? Okay, and let's just go to theory. This is graphically showing you what happened. Okay, I can draw the dialogue, the graphical structure, the logical structure, or the physical structure. And this structure so far was pretty clean. And now I have two arrows pointing to the same object, which means there's an object with multiple parents. You've seen this very graphically. And that's what the problems are. Okay? And so this is not a tree now. Okay? A tree means that every node is reachable only one way, one parent. And I'm calling it a DAG. Some of you might have heard of the term DAG. Some of you haven't. What do you think the word DAG might mean? For either way. For those of you who haven't heard it, probably it's harder. Yeah.
Directed acyclic graph.
Directed acyclic graph. And you studied this where?
I think it was graph theory.
In your high school or in?
No, just sort of something I came across.
Okay, something you learned on your own. So it's good. So whenever you draw these structures, okay, with nodes and edges between them, you are creating graphs. Okay, so whenever you have boxes connected to arrows, you have graphs. Okay, and these graphs can have various kinds of constraints on them. And when you have, so we saw what a tree is. Okay, you can't have multiple parents. And a DAG is a special kind of graph. It's not an arbitrary graph. It's a graph that is more than a tree, but less than a complete graph. So what does the word acyclic mean here? In this graph, if you follow links, can you end up with a cycle? This is not really a cycle, okay, because you're going from x-axis to y-axis, and then the arrow is going down, not up. If I had a child point to its parent or some ancestor, then I would have a cycle also. Okay, so we don't have cycles, so this is without cycles, but it can have multiple paths going to the same node. Okay, so that's a DAG. Okay, so it can have multiple paths to an object, but no cycles. And this is where we get into a fancy graph where you can go from a node back to its ancestor. Okay? And again, this is a structure you'll often want to create. You'll say, okay, in my line, let me create a link to my parent. Okay? And again, in a folder tree, we might do that, right? We might create a symbol. These are called symbolic links in the operating system. We might create a shortcut in a folder back to the parent. Okay, so now I've got a cycle. Okay, and this is again something, like I said, you guys might want to do in your code. Okay, and you will end up doing. I mean, some of you will end up doing. Okay, and now graphs have many applications. You guys, how many of you have heard of the traveling salesman problem? Bunch of you. And what does that have to do with? A graph. That you have a bunch of connected cities, and the idea is to go and visit all the cities till you come back. Okay, so you do come back. And to find some path through the graph that will lead you back to yourself and to find an efficient path. Okay, your internet is a graph. Okay, there are computers connected to other computers, connected to other computers, and you can come back and, there's many paths to the paths that you can follow. So these graphs occur in a lot of contexts. Okay? And tree is, again, something which has only got a single path to an object. Okay, so this is just saying it in text, what we already said. The tree each node has a single incoming node, and directed acyclic graph, you can have multiple incoming nodes edges to a node, but you can't return back, and in graph you can return back. So ObjectEditor does not display certain non-tree logical structures. So ObjectEditor wants your logical structure to be a tree. This is sort of tension we are facing right now. And ObjectEditor is not the only tool. A lot of visual tools have that feature. Swing and AWD have this kind of constraint also, that they really want to show trees, and we want to create structures that are non-tree. So there's a little battle that we have to fight with the tool we are using. Okay? And it's not really a battle because it's really a mismatch thing. You're creating one kind of structure, you want to display it in another way, and so we need to sort of separate what we want to display and what we have created. Okay? So now let's go and look at this DAG Cartesian plane. We have two real problems. A, we don't want to see these two locations, and we are seeing them. And two, we can't even see the whole logical tree. We can't see our tree view just bombed on us. The code just crashed on us. Okay, the part that didn't quite crash, but it didn't quite do its job. So we get something we didn't want, and when we gave that to ObjectEditor, it kind of gave up. So what's the solution? What kind of dialogue do we want with ObjectEditor at this point? Some kind of annotation that goes and says what? Not a tree. If you say not a tree, what should it do then? It should go and search the whole thing and say, and do what? So it figures out it's not a tree. So it can only take tree. So you have to go and say, my logical structure is this, but my display structure is something different. So you have to give it a display structure that is a tree, even though your logical structure that you've created is not a tree. So how can you go and give it a logical structure? What kind of annotation do you need to go and say, ignore this? That's kind of what you want to say, right? These two properties got displayed when they shouldn't have got displayed. So if you could just tell it, ignore these true properties, then it won't even bother with these properties. So what it will create will be a tree logical structure. Okay? So you had two problems. You gave it two things that you didn't want displayed anyway. And because you gave it two things, in the graphical display, they got displayed wrong. They got displayed, and the tree one, it buffed. It just couldn't work. So you just go and say, hey, ignore these two properties. Okay? And ignoring, you would go and say something like this. These are not visible to you. Okay? So you remember, for a property, you have to go to its getter method. And you have to go and put a little annotation there, and you say, this get method is denoting a property that should not be visible. And so that's what you do. Okay? So again, this is something that you might need, and that solves your problem. Okay? But the main point is that there are tree structures and non-tree structures. That's the conceptual point, and from your practical point of view, this is kind of annotation. And you can do this visible for other reasons too. Supposing you just have some properties that you don't want displayed at all. Whether they create cycles or not, you can just say ignore them from the display. So what you see is not necessarily what you have in your program. Okay? Question? Okay, so if you do that, everything, you see a tree structure here, and you don't see those 2 points. Okay? So remember, this was purely for the programmer. The programmer is lazy and they don't want to go and say, so the question is, if they're not visible to the object editor, why did the programmer even write this? So they're visible to another programmer. So somebody else that's using the Cartesian plane can go and say, give me its x-axis location in the code. And then from there go and, use. So they don't have to go and say, get x-axis dot get location. They can just say, get x-axis location, if that is shorter. So it's just that it won't be exposed to ObjectEditor. Okay, because ObjectEditor is a tool that you didn't write. And because it's a general tool. And because you didn't write that tool, you need to sort of tell it sometimes to look at it and not. Whereas you write your own code, you can say, okay, I'll ignore this property, I'll not ignore it. You wrote it. You have full control. Whereas here it's a generic tool and you just have to go and give it indications. Okay, just as an Eclipse. If you notice, Eclipse is another kind of tool that's very general purpose. And you might have seen some annotations from it, at override that it generates. And you're just talking to Eclipse or to Java in general to say, this is what I'm doing. And based on that, please govern your behavior. Okay? But again, it may be best to just not have these properties. Okay? But I do know that you can write some very elegant programs by having a central location and all the subcomponents deriving their location from that central location. Okay? And having all the subcomponents have a link to their parent, to the top level object, so that they can always point back to it and get the location. And then you would go and make the parent link also not visible to ObjectEditor. So you're just saying the display structure is not the same as the program structure. Okay? Questions? Okay, and again, when we have trees, we also can talk of, so we've got hierarchies. When we have a tree, that's a hierarchy. Okay, so then in hierarchies, you have manager, sub-manager, there's strong relationships. So every node in a tree roots a subtree. Okay, so that's a subtree of the top level tree. And so you can say this is the root, this is a subtree, this is a smaller subtree, and so forth. So when you have a tree, the structure keeps getting smaller and smaller and smaller, and that's what's happening here. Okay? So again, I might use the term subtree, and subtree is just some node within the tree that it has its own children, descendants. Okay? So now again, graphically, we have a tree root and we have a subtree root here. Okay? So this is subtrees are again things that you will hear a lot of in your courses. Okay, at this point you've got ObjectEditor to create the UI for you, and maybe you love it, maybe you hate it. You would love it because you didn't have to do the work to display the object. You would hate it because you're not in control. Okay, and then you have to have this dialogue with ObjectEditor, and you don't feel you could create the whole program on your own. You feel you're dependent on something that was given to you. And that happens. You didn't write the compiler, you didn't write the interpreter. So you are dependent when you're programming. Maybe this kind of dependency you don't want. Okay? And if we have time, then we will, in fact, have you create the whole UI yourself. And it's not as difficult as it might seem. Okay? Because we'll do it later in class when we have all the concepts in our head to be able to create the UI ourselves. Okay? And now that we've got these structures, we have the notion of structures. From these structures, we can actually understand some of what's going on in the UI properly. Okay, I can always go and give you a piece of code and say, okay, don't, this part is magic, this part is not magic, so change the non-magical part and you'll get the right thing. Okay, but what we're trying to just remove the magic from that code. So, those of you who use Swing and AWT, and I think there's maybe 2 students, or 2 or 3. So I know a lot of you have created these structures using some libraries, but some of you have used Swing direct and AWT directly. Can you see what kind of structure this is? So again, who's used Swing entry? Okay, you want to volunteer either now, right? Because I'm going to put you on the spot. But I know there were 2 students who had used it last time, and they're probably not here right now. But visually, can you see a structure from this diagram? Can you see some kind of structure? Containment structure. You have a rectangle that contains 2 rectangles that are gray colored, and each of these rectangles, and then you've got this little bar. Okay, so this visual structure is indicating some kind of structure inside. You've got this little bar here, and this gray structure has got this little text box in it, and this gray structure is called this little button in it. Okay, and so some of you haven't used Swing and AWT directly, but anybody, what is the top level rectangle called that you might have used in your libraries that you use? They might have exposed that name. So it's a window, and a window is called in Java a frame. Okay, so that's just the term. And this gray colored structure would be called, when you're talking about windows in English, you have windows with panels. Okay, so this is, I forget what, sometimes these things are called panels, sometimes they're called panes. I think Java calls them panels. And then this is a text box. Okay, there's no mystery there. And that's a button. Okay. So we have JFrame or frame is a top level window. There are 2 implementations of the same kind of object. They don't implement the same interface. I wish they did. They would have made life easier, but they don't. So that's the frame. We have some leaf level objects, JButton, JText fields. Okay. So again, we've got this terminology to describe now what we create in the user interface. Okay. And we have some internal nodes. Okay, these are neither leaves nor roots, and that's a J panel. Okay, that was what the name was. J split pane is something that splits the thing into components. Okay, so that's the structure. Now that we understand the structure, we just have to go and use an API to allow you to do that. Okay, and that API is not too complicated. We know how to instantiate objects, so we can instantiate now a JFrame. Okay, and we know that we want JFrame should not have class methods, it should have instance methods, because the same program can create a window here, another window here, another window here. So we want these to be instances. Okay. Then we've gone and instantiated this object. We've instantiated split pane. So this is the structure. JFrame goes into a JSplit pane. So you basically take something that's a rectangle, make that into a rectangle that's splittable. And then when it's splittable, it's got a left component and a right component. So we go and make the left component be one kind of object, the right component be another kind of object. Into that component, we go and add a text field and a button. Okay, that's what's happening here. And so I created the frame. I created a JSplit pane. I went and said, hey frame, adopt or add to as a child the split panel. Okay, just as you might add, those of you who've seen array lists, we haven't seen that so far in class. You might add something to an array list. You're adding something to this. Okay. Oh, very quickly. I didn't notice that time had passed. So let's just stop at this point, and then we'll carry on. Okay, let's start. So, questions before? Yeah.
So, question: why do we have a width and height in X and Y for program? Because width X and Y equal width and height.
Sorry, say that again. Why do we have X, Y, width, and height, all four properties in?
Because if you have X, that's the width, and if you have Y, that's your height. So aren't
Of what? Of a line?
Right, but wouldn't that be done as variable?
So you're talking of a line, right?
Yeah.
So a line has to be placed somewhere in a Cartesian plane. That's just x and y. It's got some length, which means it's got some, and it's got some angle, which means it's got some width and height.
Right. Okay, so, but for this assignment, our x and y system starts at 0, and the width and height is where you want to place the.
No, I don't quite say that. You're misunderstanding it. I did break it up into two parts to make your life easy. That in you know, just and you don't have to think that way. It's just that I wanted to avoid you're having to deal with math that you're not familiar with. So I said, look, here's a way to reuse my polar point. Okay. But initially, the line is at origin, and it moves around, so its width and height changes. And then the line moves also. So you need all things. If you think about it, you need two endpoints. Think about it this way, that you need two endpoints of a line. And you're saying one endpoint is enough. And it's not, right? So the width and height are just giving you the other endpoint through x and y.
And a polar angle and radius is what we set.
Yes, you.
Converts to a Cartesian plane that would ObjectEditor plots.
Yeah, so ObjectEditor is not smart enough to know your radius and angle.
Right.
Okay, but you're smart enough to know that.
Right.
So you say, okay, you know, I'll go and tell you what the width and height are corresponding to a radius and angle, basically. Okay, so you need some formulae for doing it. That's not what I'm trying to test in this course. And that's why I gave you a path to implementation that would just use something you already seen in class. Right. And you say, oh yeah, I can just use it this way. Okay? So it's not, in fact, if you know the geometry, going through that tedious process is not good. That's why I put it in very small font. Okay, it's that if only you want it, you get it. Okay? Yeah.
If you double for the angle, ObjectEditor throws an error.
If you have a property of type double, because ObjectEditor has no idea what an angle is. Okay? So it's going to just look at properties. And it says there's a property called angle. Who knows what that is? And ObjectEditor, as far as I know, displays doubles. But there's always bugs possible. Okay? So if you're convinced it's what error did you get?
I don't remember, but basically every time I'm putting double insertion feature, I'll get an error.
Okay, so just remember you have to be consistent. If you say get double, get angle double, then you have to set angle as double also. You can't say, oh, I'm going to get it as an int and set it as a double. Okay? That will confuse ObjectEditor because that doesn't follow the bean property. And it could do with that, but it wants to make sure that you can see your property naming violations. Okay? So just go and see what the error is. If you look at the errors, they're pretty explicit, but they're not guaranteed to be. Okay? As you've seen in software you use, sometimes you just get a blue screen. So if you don't get a blue screen, you're doing, programs are doing all right. Other things? Okay, so if I go to Sakai, I see 187 students, and I've never taught in such a big class. I don't have a good idea what the number here is, but I think it's less than that. And I have to periodically go and give reports on who's attending, who's not attending, and what the status is, especially for freshmen. So I'm passing around a sheet with your names in it, and just sign next to it if you're in the class. Okay, and do make sure that you sign before you leave. Okay. And again, I want to reiterate something I said at the beginning of class, that attending means attending the whole class. Doesn't mean leaving in the middle of the class. Okay, I saw a couple of people do that last time. And you do that, the TAs will come talk to you. Okay. Other things? Anything on the material? Class? Yes. There's an attendance sheet going around. Going by. Just sign it. That's it. Other things? Okay. So last time I gave you a preview of what you're going to see a lot of in future courses. I said I drew these boxes. I drew edges between the boxes. The boxes were called nodes. The edges were called the links. The lines were called edges. And you're going to, in future courses, just see an abstraction of this. You're going to say, imagine a graph. And you're going to see all kinds of ways of storing the graphs, of writing algorithms on the graphs, and so forth. Okay? But since this is a programming course, I wanted to give you a concrete idea of what these graphs might mean in real life, okay, in quote-unquote practical applications. Okay? So we saw one application, and this was Cartesian Plane. And actually, we saw a more complicated application also, which was a shuttle, a plane on a plane, okay, or basically a shuttle location. And we saw that it could be decomposed into components, and we saw there was a notion of a logical structure. And these logical structures are defined by properties. Okay, so this is why properties are important. And we saw that we could create fun kind of structures. Java will let any property point to any object on your computer, in your program. And one of these things we created was what we called a DAG. Okay, it was a graph. Okay, anything that has nodes and edges is a graph. It was a graph in which you didn't have cycles. Okay, so these are directed edges. These are arrows that have a certain direction. You can't go reverse. You can't go against the traffic. Okay, so if you follow the traffic, you can't come back to a node you started from. Okay, so it's directed. It's got edges, directed. Acyclic. It's got no cycles. Acyclic, and it is of course a graph. Okay, and we saw that ObjectEditor. It shows both a tree view and a graph view or a drawing view. The drawing view can handle such a thing, but the tree view cannot. And it'll start, not quite giving you a blue screen, but it'll start complaining. Okay? So that's why it was important from a practical point of view that if you created such a structure, you better beware. Okay? And then we saw, so that was a DAG. And then we saw we could even be more complicated. We could have quote-unquote child nodes point back to their parent, to the parent nodes, and then the child-parent relationship doesn't even make sense. Okay, so in a DAG you can have multiple parents for a child, but you can't have cycles. But in a graph you can have actually edges going back, and that gets far more complicated. And I told you, the web is a graph. The traveling salesman problem defines a graph. So there's a lot of graphs in this world. Okay, and then we saw the simplest form, which is the form we like, which is easiest to deal with among all the graphs, tree, where every node has a single parent. Okay, so you don't have multiple parents in a node. Okay, and some of the code I showed you was not meant to be digested in class, and I'm sure some of you weren't able to digest it. And it was mostly to do with placement in geometry, which again is something I'm not emphasizing. I mean, that's something you'll have to use to create an interesting project. And so because things got so complicated, in fact, the structure was even more complicated than this because we embedded a Cartesian plane in another object. Okay, so there was all this code that I kind of brushed by and said, look, you guys will have to do something like this in your project. So this is just a template for you to have a look at, how to go in, where to call your placement routines, call them in the set method. Don't replicate code between the constructor and the setter. So that's the kind of point I was trying to make. And so, but the details weren't something that I looked at very much in depth. Okay, and we're going to now look at a problem that lets us abstract all the details even more. Okay, we're not going to create the objects that we're going to link together. We're going to use some objects that Java gives us. Okay, and we're just going to do the job of linking them together. Okay, and again, this is practical because you create today. There are a few programs that don't have user interfaces in them. This has to do with the user interface. Now, the user interface for you is a bit of a mystery because it's handled by ObjectEditor. Okay, but we'll demystify that soon. Okay, and this is part of the demystification process. Okay, we are starting that here right now, and we are saying something as simple as this. Okay, which is which has got some visual containment, is actually an implementation of something that is in fact a tree. Okay, so and you can imagine that if some box is contained within another box, then the contained box is a child of the containing box. Okay, that's how user interface software is typically designed. And there are all kinds of rules about, if the parent is colored blue and the child is colored green, what is the area under the child, what is the area under the parent that's not under the child. Okay, so there's all kinds of interesting rules there. But these rules can be only enforced if you have the parent-child relationship. Okay? What happens if the parent is removed, then the children also get removed. So this relationship is really is used in the implementation. Okay? And we saw that, look, what you call when you, as an end user, when you use something, we say this is a window. Okay? And a window is the standalone thing. It's contained in the screen, and it's just displayed in the screen. It's not really contained in the screen. So the window is the root of your user interface. Okay? So that's a frame. That in Java could be a frame object, or it could be a JFrame object. Okay, so there are many ways to do these things, and Java has got these multiple ways. Okay, like I said, it would be nice if both JFrame and frame implemented a common interface. A lot of things would get easier, but they don't. Okay, and that just shows that interfaces haven't been used as much as they could have been. So I create the top-level root. Okay, and Java libraries. Many of you are somewhat surprised by my rule that every variable should be declared of type interface. And you probably say, hey, I see Java code that's industrial strength and everything, and it doesn't follow this rule. So, maybe I'm just living in this artificial world for a while, and as soon as I get a release and go out into the real world, I can do what I want. Okay, and I don't think of myself as an impractical person. And it's just that I've seen the evolution of Java, and I got to tell you that Java didn't get created to teach you guys programming. Okay, Java was created by a guy called James Gosling. He did it for himself. He was making set-top boxes. He wanted to make these embedded computers, and he didn't like C++. So he said, let me go and invent my own language. And he was sitting in Sun. He was a researcher, and it just took off. And it took off mainly because of the internet. At the same time he was inventing this language, a lot of people had invented very nice languages, and they just didn't take off because, quote unquote, they weren't practical. There wasn't a compelling reason to use them. You couldn't do, and compelling reason doesn't have to do with how you program. Okay, that people say, oh, we can deal with that, we'll live with that style. Compelling reason is that you can do something you couldn't do earlier. Okay? And when the web came around, there were these HTML pages that were very passive. There was no JavaScript at that time. And there were these passive things, and you could just go and look at what was happening. You couldn't do an animation in the page. You couldn't have it do a lot of fancy GUI stuff. And what Java did was they said, okay, we'll allow programs to be sent from the HTML server, from the web server, to the browser. We'll allow you to dynamically put any arbitrary code into your browser to do arbitrary things like animation and so forth. Okay, and Java was the language that allowed you to do that. Because there were things called applets. I don't know how many of you have even heard of applets. They are not in vogue right now. And just because people are afraid of this arbitrary computing happening on their computer, computing written by somebody else. Okay, so but that's how it became very popular. That you could just have these pages that were very alive, and Java was the only language that allowed you to do that. And it so happened that Java was in many ways cleaner than C++. So it was, educators like me said, oh, let's use Java now as a practical language. Plus, it's nicer than what it was. Okay, and so again, this is just to say that Java has interfaces. There's a reason it has interfaces. But a lot of the people who built Java libraries haven't followed the good programming rules. And just because they haven't followed them doesn't mean they're good rules. And so I'm typing this using the same class name because I don't have an interface. Okay, and because I don't have an interface, again, let me reiterate, I can't go and change a JFrame with a frame. Okay, interchange. And this to me is a real problem. I've designed ObjectEditor. ObjectEditor is not trying to implement the functionality of a frame. It just wants somebody to do frames for it. It would be nice if today the ObjectEditor could be used with Swing, which is JFrame, or AWT, which is frame, or SWT, which is another toolkit, or GWT, which is Google's toolkit. Okay, SWT is IBM's, and it would be nice if I could just write some software that goes and runs on all four of them. Okay, but I can't quite do it directly. In fact, I had to go and re-engineer these four systems, create my own interfaces, and actually ObjectEditor will run on all four things. But I had to do a lot of sweating because these guys didn't create interfaces. Okay, so going back, we've got this frame that is a top-level frame. Then there's this little divided frame. Okay, so the top-level frame is a vanilla frame. You can do anything to it. Into that frame, we've put a little frame that can be divided. Okay, so it's a partition frame, and it's got a left part and a right part. Okay, so this partition part, the partitionable part, or this pair of frames, I add a pair of components I add to frame. Okay, that's my split pane. Okay, so I create these nodes individually. I say I've got a split pane. Split pane on its own cannot be displayed, but it can be created, and I put the split pane into my frame. So I'm now making an edge. Okay, that's what I did here. J frame has one child, which is a split pane. Split pane, by definition, has two parts. Okay, a left part and a right part. And those left part and right parts could be anything. You can put any kind of component into it. And the component I'm going to set as the left part is a panel. Okay, there's a J panel, there's a panel. You can imagine there's multiple implementations of all of these things. Okay, so this just happens to be a J panel. And I'm going to also create a text field for this. That's the real work, right? That's a leaf level node I'm going to create. Okay, so that's the left text field. And I'm going to add to the left panel the text field. I'm going to create a button. When I create a button, I can go in the constructor, say what kind of text it should be. So it says press me. And I'm going to add to the right panel the button. And this is where I went and set the left and right component of the panel. So I've created this whole structure. And you can set the size of any panel, of any component. And I've gone and set the size of the parent. And by setting the size of the parent, automatically the children components get adjusted. There's all this magic going on in these widgets. What are these things are called widgets. That's not a very creative term, but it's just something that's displayed on the screen. Okay, and if you create something, it doesn't have to be visible. Okay, so can you guys imagine why I had to have a special call to make it visible? Why not just? I mean, these components are meant to be visible, so why not just make them visible automatically? Why have a set visible routine? Anybody want to guess? Yeah.
In case you have a program, you press a button and a window pops up.
And you press a button and a window pops up. So why shouldn't the window? Oh, so you're saying the window is already created, and you just make it visible. That's good. So you don't want to create the window when the button is pressed. You just want the window created, and you'll just make it pop up, and then you can make it hide, then you can expose it again. Okay? You don't have to do this again and again. Supposing I'm just creating the window for the first time. And only once, yeah.
Don't you want to have things finished drawing or whatever, loading before you display to the user?
So don't you want to finish your job before you display it to the user? Do you really want the user to see things incrementally coming on the screen? Now, if you guys have used the web browsers, you notice that things come incrementally. And at least you get to see what's happening. And sometimes that's good, but sometimes that's bad. Okay? And the whole point is, you add one component, the computer goes and redraws the whole thing, says, oh, I got one child. Now you add another component, it redraws again. So it's just doing a lot of computation that was not even necessary. So let's just get the whole layout together at one time and then say, make this. Okay? This is what often you call a transaction. Okay? That you're going to go and do a bunch of things that you want done atomically as one unit. Ashley?
If you had more than just like two panes or panels, how would you set them like separately? Like the most left, the center, the most right, if there's like four things.
That's a good point. So what if I wanted 4 components here? And I have a split pane only with 2 components. I could do what?
Could you add split panes to split panes?
Could I add split panes to split panes? That's the joy of hierarchies. Okay? That's what you do when you create trees. Okay, you add, that's how the population grows also, right? You just add parents who add children and so forth. Okay, so that's what you would do. But that's a good question, yeah. Okay, other questions? So you see again the point was that this tree at least is a useful structure here. And visually what you see is inherently a tree. So visually you see 4 components. Sometimes what you see visually is not being captured is not capturing what the internal structure is. So if I see 4 panels there, I don't know whether there's a parent with 4 children or a parent with 2 children, each of which has 2 children of its own. Okay? So it's a little ambiguous. You can't go from visual to tree, but you can go from tree to visual. Okay? Okay, so I have this power right now. I can create these nodes and I can link them together. And it so happened that I link them together in this particular data structure. And I can create other data structures with split panels, and so forth. And it so happens that I have this data structure is a tree. Could I, with the tools I've shown you, have created a DAG where a child has multiple parents? With the API I provided you, could I even do that? Firstly, we have to understand what it means. Let's not try to figure out what it means. Who knows what it means? Yeah. So you could go and you can say set left component, left panel, and you could say set right component, left panel. It's a panel, remember, it'll take any panel as an argument, and you could do that. And any idea what Java will do in that case, Swing will do? Sorry? Make two identical panels. So just make a copy of the panel. So that would be very good semantics. And maybe they should have thought of that. But what else could it do? I mean, remember, objects are passed as addresses, not as copies in Java. Okay, so when I go and pass left panel, you're saying, this is the object. If I wanted, I could have copied left panel and passed it. Yeah. So it'll have the same address of both of them. Okay, that's what I'm doing. And I'm basically making this split panel, this guy have, would this actually create a DAG? Did this really create a DAG? It created a left panel, this is actually a separate problem where we don't really know the semantics are, that its left panel and right panel are the same object, but each object still has one parent, right? So maybe this is not quite the example. This is more confusing. And who knows what it should do? I don't even know what it does in that case. But could I have a node have more than one parent? Maybe I could go in, rather than do this, I could have said left panel. So what could I have done? Add text field to the frame, perhaps. Also, add text field to this particular left panel. I could add the text field also to the frame. Then I would have two different patterns. Yes, I can give titles to windows, but how's that? Oh, so again, you're being very creative, right? And we don't know what the semantics would be, but I could do something even simpler like this. We don't know what the semantics are, but I could create a structure like this, and now I've got a DAG. Okay. And as it turns out, and in this case, I like your semantics. You want to give some semantics here too? That same text field in two panels. We tried everything. Create a copy, okay? Maybe make a title. But Java, as it turns out, is going to say, oh, you meant first that I should be a child of this particular panel. Now you mean you should be a child of this. So you are the adoptee of whoever has latest adopted you. Okay? So you can, this is more like an adoption relationship. It's not something inherent. And today you are with this parent, and now you're with this parent. Okay? So the DAG is converted to a tree. Okay? I tried to create a DAG like this, but it did not really do that. It said, okay, I will go and remove the edge from this parent, and I will put this edge. So first the edge was here, then the edge became here. It's not as if both edges remain at the same time, even though that is what you think you are doing. Okay? So we tried to create a DAG, but it didn't like that. Okay? Now can I be even more ambitious, okay, and create a cycle here somehow? I can add any node to any node. I can make any node a child of any node. So I could go and say split pane, set right component, right panel add split pane. Legal. I mean, it's allowed by Java semantics. They're both components, containers. You can just pass one to the other. So you're saying, okay, right panel is a panel that can contain other children, any other child that is a component. I'm going to make my parent my child. Okay? And of course, and so I don't know who's parent or who's child here, but we basically have edges going from here to here and here to here. Okay, so I'm now, who knows what the creative semantics are going to be here. Okay, and Java will just go and say, no blue screen, but it'll just say, you're being bad. Illegal argument. It says, yeah, the type rules allow this to happen, but we don't just use type rules. We have other rules also, which look at the semantics, not just the structure and type. And this just doesn't make sense to me. So you better fix your program. Okay. So again, the point I'm trying to make is that there's all these structures, and some structures are more complicated than other structures. And tools that work on these structures, will sometimes take a simpler structure and not a more complex structure. Okay, a tool that takes a complex structure can always take a simpler structure, of course, but not vice versa. Okay? Questions? Okay. So, so again, we have window structures and other structures, and these are just regular structures. And some window structures happen to be actually beans. Okay, when I said set left component and set right component, that was all familiar stuff to us. Okay, that was just a bean with a left component property and a right component property. Some structures are collections, and we'll hopefully get to those in a few minutes. And JPanel was not a bean, okay, but it was a collection, and in a collection we can add components that are an arbitrary number. Okay, so we just say add. We don't say add left component, add right component. They're all components. Okay, whereas split plane says, I just know about 2 people, left and right, and that's all I can have. And you want 4, you just create a child that has got a left and right. Okay, so and again to just show you in what you are actually using in your programs, just to show you what's going on. We've got 2 structures here, right here. We've got the logical structure of the object, the Cartesian plane. Okay? And then we've got the window structure of the UI that is being used to display the object. These are 2 different structures. Okay? And I've given you some idea. So far I've been focusing on just your object structure. Okay? Now I told you there's a window structure also. And ObjectEditor will in fact show you visually both structures. Okay? To go and see my object structure, you guys have seen that. I go and say tree, and I see my logical structure. This is what I program. This is what I know about. This is what I see. And I can go and validate that what I intended is what I got. Okay? And you can also go to the same menu, and you just see here, display complete widget tree. Widget, again, is just something that's displayed on the screen. And I can go and say, okay, ObjectEditor, what kind of structure did you create to display my logical structure? And it says, oh, I created something called an AWD Container, which is really a frame. And it's got a split pane. And you see these funny names that are not quite Java names, because like I said, I created a layer above AWT and Swing and SWT and GWT that unifies them, and it has my own interfaces so that I can change one from the other. Okay? And so, but they give you an idea that you've got a frame, you've got some containers within it, and this structure is something you don't have to worry about. But I'm just trying to make a point that there are these 2 structures. If you really want to know what ObjectEditor really does, it takes your logical structure, uses some rules to map it to a window structure. Okay? And I tend not to show you the displays in your assignments because I know you'll get too obsessed with the UI. But I'm teaching you how to create logical structures. I'm not into the UI structures. Okay? If your logical structure is displayed, be happy. You want to be happier and go and influence how it is displayed, I'll tell you a lot about it. ObjectEditor has got a lot of customization features. And based on what people have asked me in the past, I sometimes go and put that at the end of the assignment, saying if you really want to use it, you can use it. But I'm not going to give you extra points for using it, and I'm not going to take out points for using it, because that's not the point of this course. Okay? But this is what it really does. And for it to know what your logical structure is, you have to comment or your program properly. And by comment, I mean things that another tool can understand. So annotations, proper names, and so forth. Okay? So that is why you say, oh, I don't know why ObjectEditor is doing this. That's because it doesn't know what logical structure you created. That's because you didn't follow rules and create the logical structure. Okay? But that's what it's really doing. And the window structure just doesn't matter. Okay? You can have a lot of variety. Okay. Questions? Okay.